15.227 involves a circular plate shown right here that rotates about the y-axis there with omega 1 of 10 radians per second. And we know that point D on here is a point that's moving with respect to that disk with a velocity or speed of u of 1.5 meters per second. And we're wanting to find for a theta equal to 30 degrees right here, what is the velocity of point D and what is the acceleration of point D. So the thing to note here is that the disk right here is not spinning in this direction, it's just spinning about the y-axis. So that's going to be our little XYZ reference frame then. It's going to have an omega 1. So omega 1 is 10 radians per second J. Our U is going to be 1.5 meters per second, and then we need to get a unit vector that's in the correct direction. Well, this vector right here is making an angle of 30 degrees with respect to the y direction. 30 degrees with respect to the y direction is a vector that's in the first quadrant, and it's going to have a sine theta I plus cosine theta j unit vector direction then. So that's the direction of my u vector. The velocity of d can be written then as the velocity of d prime plus the velocity of d with respect to the frame. The velocity of d prime is going to be equal to omega 1 j crossed into the rd prime slash c, and d prime slash c is a vector that runs from here out to there. So it's an angle, a third quadrant angle there with a value of r for magnitude, and it's going to have a cosine theta I minus sine theta j for its direction. And then you got plus u, which we've already written out right here. So when you combine all your terms together out of that, you'll end up with 0.75 meters per second I plus 1.299 meters per second J minus 1.732 meters per second K. To find the acceleration of point D, you'd write it as AD prime plus AD slash F plus A sub C Coriolis. And your AD prime is this term right here, two of them. One of them is going to be an alpha crossed R, the other is going to be omega crossed into omega crossed R. So my R again is the vector that runs from C to D, and so that's R cosine theta I minus sine theta j. My alpha though is equal to 0 because this angular velocity omega 1 is a constant in magnitude and direction. So we get no contribution from that term. The omega 1j crossed into omega 1j crossed into R, we do get contributions from it. And then your A sub D slash frame. So imagine that omega 1 was equal to 0 again, and what is the acceleration of this point right here at that time? It's moving at a constant speed in a circle, so all it's got is a v squared over r type thing, so it's going to be a u squared over r, and pointed back towards C, so cosine theta I minus sine theta j, which points in this direction with a minus sign, then in front of it points back in that direction from D to C. And then you got your Coriolis term, which is 2 omega 1 j crossed into u, u being again this expression up here. When you collect all your terms together and simplify things, you get minus 27.1 meters per second squared I plus 5.63 meters per second squared J minus 15 meters per second squared K.